You're welcome. In this video, we're going to be taking a look at the law of sines. So you can follow along in your notes packet to fill out some information about the law of sines, which is Theorem 851 from your book. So when do we use the law of sines? We've been looking at a lot of tools of how do we calculate, find missing parts of triangles. So the law of sines is a tool that lets us extend our trig beyond right triangles. So our right triangle trig we can use for any right triangle. So that's SOHCAHTOA, any sine, cosine, tangent, using those relationships of sides. The law of sines allows us to find missing parts in triangles that are not right triangles. So what the law of sines is it's a ratio of corresponding sides and their opposite angles. So the side is that lowercase level in the denominator here, and the ratio of the sine of its opposite angle to that side length is equal to the ratio of any other angle to its opposite side length. So we can write it that way, or we could also flip that over and write it with the side lengths on top, just like we could with our proportions that we wrote before. So the top options, the sine of A over A equals sine of B over B, is great for when we're looking to find an angle because it's already in the numerator. Whereas the bottom option is a little better suited for when we're trying to find the length of side because it's already in the numerator. Either way, you could use either option. Your algebra is just going to be a little bit simpler if you make a smart choice about how to set up your proportion, just like it was back when we were looking at our similar triangles and setting up proportions. So when can you use this? We can use it anytime you know a side and its opposite angle and one other piece of information. So that other piece of information could be a side or an angle. So if we think back to kind of how we talked about our triangles in our congruency, essentially what we're knowing here is angle, angle, side, where we know two angles and a side that's not between them. Because here we know angle A and the side opposite angle A, and then another angle, or side angle. So here we know side AC and side AB, and then angle B. And that angle B is opposite one of the sides we know, and then we know one other piece of information. So let's look at actually utilizing this to find some sides and angles. So this first example here, we're going to be looking to find the length of side AB, which is also labeled with that little c. We can use that lowercase letter of the opposite angle to talk about a side length as well. So setting up our law of sines, I'm going to use c over sine of c equals b over sine of b. Putting that c in the numerator just to make the algebra a little easier to solve. Again, you could do it the other way. It would just be a little bit more algebraic manipulation to get c by itself. So once we have this proportion set up, making sure that we have our side over its opposite angle, to solve this, 7 over sine of 35 is just a value. You can type that into your calculator and get what that is as a decimal. The only thing we need to do here is to multiply both sides by the sine of 105. So that will look like this. You can just do that then in your calculator. Once you type that into your calculator, you should get that C is about 11.8. Go ahead and try that in your calculator just to make sure that you are following along and getting the correct information. So if you need to pause this for a minute to try that, to make sure that you can utilize the calculator as well, please do so. The second one, we're looking for the measure of angle R. So it's labeled here with an X. I'm just going to use that X for simplicity. Since we're trying to find the angle, I'm going to put the sine in the numerator. Again, you could do it the other way. It would work fine. You just have more algebra to do. So sine of X over 41, since 41, that side PQ is opposite X, is equal to sine of 39 over 28. So in this case, you can see that they gave us this side angle compared to the first example where we had angle, side, two angles and a non-included side. So once we have our setup there, it's going to be a little bit more to solve for an angle just because we have the sine of that angle. So we're still going to start by multiplying both sides by 41. But once we do that, we also have to undo this sine function. So we practiced doing this when we were just using our trig ratios in right triangles. To undo the sine function, we're going to use the sine inverse. So the sine of 39 divided by 28 times 41 is just a number. You can type that into your calculator and figure out what that number is and use that second answer to take the sine inverse of that second answer, or you can type in the entire thing as long as you make sure that you have parentheses around what you're taking the inverse sine of. So once you do that, you should get that measure of angle R is about 67 degrees. So again, if you need to pause the video, take a moment to see if you can do that in your calculator and follow along and get the same correct answer here. That's all we have for the law of sines. So make sure that you have filled out your notes and now you are set to go do some practice on your own. Thank you so much for watching.